Hello, students. Before you guys get started, I just want to make sure that you have out your calculator so that you can follow along with the examples in practice, as well as your pencil. You can take notes in your packet or you can take notes in your notebook. It's your choice. With the person who's playing the video, just pause to make sure that everyone has out everything that they're supposed to have. All right, so today's objectives are to describe the property of charge, as in what is charge, and to use Coulomb's law to calculate the electric force between two charges. You know, the thing about charge is that it's one of the fundamental properties of matter, and there are actually four specific fundamental properties. One is mass, one is position, one is the time at which the object exists, and the other is charge. We don't really know why time passes. We don't really know why objects have mass. We just know that they do. And we don't really know why objects have charge. We just know that they do. And just like all the other fundamental properties of matter, we know their effects. We know that having a position at a certain time has an effect. We know that having mass has an effect, and we know that having charge has an effect. But we don't really know exactly why objects have those properties. So what is charge? Like I said, we don't know, but we do know what it does. Electric charge is a property. It has nothing to do with the size of an object. Charge can be either positive or negative, and we have given charge the unit of coulombs. If an object has no charge, it is neutral. So charges can actually be added together and subtracted from each other. So here's a question. This is our first example. What would the charge need to be added to a charge of positive 6 coulombs to have it reach a charge of positive 1? So positive 1 coulombs is the goal. And we are starting with positive 6 coulombs. So we have some charge. Here it is. It's positive 6. And we are going to add some Q, a second Q, a second charge, and we want it to equal positive 1 coulombs. So what should Q2 be? Well, we could subtract 6 coulombs from both sides and get that Q2, the second charge, should be equal to negative 5 coulombs. And that would be our answer to that. So if we had plus 6 coulombs and we added minus 5, we would get positive 1 coulombs. So that was pretty easy, right? Let's talk about Coulomb's law. How can we describe the electrostatic forces? This is Coulomb's law. Please copy down Coulomb's law into your notes. This F here could have a little E under it for electric force, and it equals K Q1 Q2 over R squared, where K is Coulomb's constant, Q1 is charge 1, Q2 is charge 2, and R is the distance between them, and R is squared in the formula. So just to draw it out in a picture, here's Q1, over here, here's Q2, and R would be the distance between them. K. K is 9.0 times 10 to the 9th power. These are the units for K, Newton meter squared per Coulomb squared, but really this is the important part. K is 9 times 10 to the 9. So 9 times 10 to the 9 is actually pretty easy to remember. So going back to this formula, I'm wondering, do you guys recognize another formula that's kind of similar to this formula. How about gravity? So this is the force of gravity, as you remember, and here's the electric force. K Q1 Q2 over R squared, or G M1 M2 over R squared. So really similar. And gravity and the electrostatic force are both fundamental. So it leads a lot of people to ask, what is it about the universe? What is it about the universe that leads to equations like this? Some fundamental property of the universe. All right, so here we go. An example. So here's where your calculator is going to come in handy. Example 2. A positive 1 times 10 to the negative 5 power Coulomb charge. So here's Q1. It is 1 times 10 to the negative 5 coulombs. Is placed 0.25 meters away, so 0.25 meters away from Q2. Another charge, which is negative 4 times 10 to the negative 5 coulombs. And the question is, what is going to be the force attracting them? Because they would be attracted. Positive and negative attract. Well, we calculate our force by the new formula you guys just learned, which is K Q1 Q2 divided by R squared. So 9 times 10 to the 9 times Q1, which is 1 times 10 to the negative 5, times Q2, which is 4 times 10 to the negative 5. Notice I did not put in the negative. Divided by 0.25 squared. All right, at this point, I want everybody to be doing the calculations, and I have a recommendation. We're going to calculate everything from the top and put it at the top, and we're going to calculate the bottom and put it at the bottom. So, 9 times 10 to the 9. Times 1 times 10 to the negative 5. Times 4 times 10 to the negative 5. That comes out to 3.6 divided by 0.25 squared. 0.25 squared is 0.0625. So these two divided gives 57.6 newtons. And that is the answer. All right, second and last example here. How far away? Well, how far away? That's going to be asking for the distance, which is r. Would a Q1 of negative 1 times 10 to the negative 5 coulombs charge need to be from another charge, charge 2, which is negative 1 times 10 to the negative 5, to have a force of 10 newtons? Well, this is going to be a pretty complicated problem. We're going to have to solve for r. And r is something that is in the denominator, and it is going to need to be solved for. So what we need to do is multiply both sides times r squared. What you get is fr, let me just erase that right there. What you get is f r squared equals k q1 q2. Then divide both sides by f. Those cancel out, and you get r squared equals k q1 q2 over f, and then square root both sides. So you get r equals the square root of k q1 q2 over f. And that is now a formula that can be used to solve for r. So r will be the square root of 9 times 10 to the 9 times 1 times 10 to the negative 5 times 1 times 10 to the negative 5 divided by 10. So I'll give everyone a chance to do that in their calculator. All right, oh, and I just noticed that this is as if the 15, this actually should just be negative 5. All right, so I got an R of 0.3 meters. All right, and that is the end of today's lesson. It is now time for you guys to practice. So make sure that you finish all the practice problems, because tomorrow we're going to pick up and move on from here. There are answers on the practice. Look on the back of the page. Good luck.